Okay, ladies and gentlemen, I mentioned in one of the videos a flyover from Bumblebee. I said, "What's with this right here, this flyover?" I said, "I remember it being a bin full of concrete inside the video." And we talked about this debris field that it's things have turned over, and I wonder what went on there. And at the last minute, my brain got it down here, and it said, "Oh, the cranes dropped on it." Um, and you can see that things are turned over there. Let's do this. Let's do the cranes. And as this falls down, this is what's going to cause all this strife across here. So right about there is our impact. I use triangulation here. I can come across the corner, come down and try to figure this out. Go to Bumblebees, and we come across the corner, high corner, the length of it. I'd have to figure out the length of this total crane length. Try to figure that's another whatever X amount of feet. But there's the angle right here. And let's see if we can do this. We do have a debris field. I was trying to see if it impacted and broke the concrete decking here. I cannot find that took place. I don't see it. This decking, a diaphragm interaction work back on this section of this zone took a hell of an impact, right? No big deal. It took a baseball bat swing to it with steel that's never been done before. No experiments ever done this, and this would be very telling and data they should be snatching up, especially engineers, so this can be put out in reports talking about how how you can extrapolate what would happen here. They should be up here measuring this, checking it out, and everything. But no one did it. They had a chance to put some pads up there to take calculations, but no one did that. Now it's almost a crime not to bring a crane up here and take this equipment off. It's still some great equipment. The equipment didn't do any harm. Why are they trashing this equipment? But this is the oddest thing here, right here. Got these multi pallets. Let's watch this drag. Now watch it pull the bucket off. Nope, I don't see that. Right now it looks about parallel. And it hinged over at that point from here. Swing it, tearing it off, swing it over again like a baseball bat again. And there's a second swing. And this video shows the big concrete bucket. So this bucket came down now. This is going to pollute the whole idea of debris and everything else. This is where that path was. There are the 1, 2, 3, 4, 4 1, 2, well, that's 3 pallets, 4 and 5. So it's got concrete on it. Oh, it's got a piece of wood on it. So we're trying to figure a path. There's a piece of wood. As you can see, that wood is still in place. That piece of wood right there, still in place. It was able to, this path took out these columns. We're going to count the seated columns in a minute or not. And these columns took down see the 1, 2, 3 columns, and here's a shadow of a column. Those columns did the deceleration of this. Let's confirm the location again. These 2 columns did the deceleration of that crane because these columns loaded on top of, I don't know if it's a beam here or not. Look at the impact that thing was able to take. So these 2 did the deceleration. These 2 guys, was it 2 of them or 1? Was it these 2? I think it's these 2, right? Shadows on this one. These 2 took the forces. Yeah, I guess it's red. There's a shadow, red. And there's a shadow, red. And then there's a gap. 1, 2, 3, 4, 5, 6. Those 2 did the deceleration of this. Why we don't see the crazy impact. And there's the path it took. I guess those red beams went off the building and became projectiles. It hit the back of that bucket. It when it came off, it grabbed the front of the bucket because there are the 2 pallets remaining, or maybe 3, not too sure. And that might be the path right there, the score mark. and then off in that direction it went. I'm just sharing data with you. This is stuff how I look at all this stuff and learn, and this is how I'm able to look at this debris field and start reverse engineering things by looking at things like this. So that's the path. That explains why the deck was able to take that major impact initially, because it didn't take it initially. This took the initial impact of the downward swing of the jib. 1 and 2. Maybe they got entangled. Maybe they flung off like a broken nail, like you're driving a nail in there and it popped off and flew each direction. Who knows? And I guess you would know if you find it down there or in another building somewhere. It took that pallet out. Didn't take that pallet out. That pallet went bye-bye. Yeah, that pallet and the cinder blocks also went bye-bye. So we don't even see it there. But right there is where it's probably hitting those red. I'm playing it. Right here, see the red in the back, the columns in the background? It would be these two. Right there. I believe that's the impact of the 1 and 2. That caused the deceleration of this guy. Now it's hung up or something, because we get this kink here at this point. Maybe it's still hung up on that, tearing those off. And maybe that's it there. Maybe that's it there. I don't know. Right? I see debris falling. There's that projecting, swinging back around. And this was supposed to be with the least impact, so we missed that thing go down. I mean, maybe it slapped it so hard, maybe it slapped it off the backside of it. This is the concrete, this ton of concrete here, debris. Well, the pallets are there, so 1, 2, 3, 4, 2 pallets that made it. So it didn't just, it did. I don't know how that. I don't know where that went. Maybe it went. No, it didn't go down there. Well, let's look at the configuration of this. These are not touched. There is a red rope there of some type. Maybe the lanyard. The rope appears to be right there too. So that appears to be the path. That we missed it being dragged off somehow or projected. Maybe when this hit, it popped it, and maybe that steel hit the back of it and giving enough force to like a baseball bat again to drive it off. I don't think it went across here. There's something in the path there. All this is in the path here. I think this is the path, and we just don't see it. I'd like to see that in another video, but now this explains why the impact, about this impact. And it would be very interesting engineering-wise to look at the columns below this and the steel below it and try to calculate what the forces were, or roughly call it dead weight impact from a certain distance, and see what happened there. The wall system, we talked about that. How much did they make it out there? I think right about here is where they were going to start building the storage area. I don't know. There's a stockpile of materials here. Let's jump into what I was going to present to you today also. So I wanted to give you that for a little teaser. Then we'll jump right into Osha. This will be significant for this structure and also the structure in Ohio. If you want to search this United States Department of Labor products, you're going to go to 1926. 1926 is going to be your lead number, 703. Let me give it to you to make it easy for you. 701, 702, and 1926, 704. So basically, you can go to 700 and go up to 706. 1926, 700 to 706, and you pull out the one you don't need, which is 705. I believe 705. So this is going to be addressing formwork, and what I'm going to show here is that, well, let's let it read. General requirements for formwork. General requirements. Formwork shall be designed, fabricated, erected, supported, braced, and maintained so that it will be capable of supporting without failure all vertical and lateral loads that may be reasonable by anticipated reasonably reasonably be anticipated to be applied to the formwork. You understand what Jeff just said? Reasonably be anticipated. So with reasonably, meaning it's subjective. You believe that this is the forces, and so you're going to say, well, this is the formwork I'm using. Formwork which is designed, fabricated, erected, supported, braced, and maintained in conformance with the appendix to this section will be deemed to meet requirements of this paragraph. So if you think it's reasonable and you're qualified, you have some, you can back up why your reasoning behind it, and it sounds reasonable. Why that sounds reasonable, then you're good to go, because they're using reasonable, not any other strong format. And it will be a bit of a strong format down here, but still it will still come down to reasonable. Drawings or plans including all revisions for the jack layout, formwork, including shoring equipment, working deck, scaffolding shall be available at the job site. Well, where else would they be available, right? Shoring and reshoring, meaning you got to have it. Shoring and reshoring. This is what we talk about with this structure that we just saw exploding. Whatever. I got FIU in my mind. It's Hard Rock Hotel. All shoring equipment, including equipment used in reshoring operations, shall be inspected prior to erection to determine that the equipment meets the requirements specified in the formwork drawings. So this is so vague. This means you can't say, I think it's okay. It says it shall. It shall. So your equipment you can't use as an excuse that I thought it was okay. It shall. It means it must. Shoring equipment found to be damaged, that its strength is reduced to less than required, shall not be used for shoring. So you can see you can have damaged equipment. It just needs to meet the loads that you currently are going to apply to it. Erected shoring equipment shall be inspected immediately prior to, during, and immediately after concrete placement. Look at the issue here. Erecting shoring equipment. So that's all equipment, right? All the braces shall, meaning must, be inspected immediately prior to, before you start doing, and look at this part, during. This means you do get to send a worker down there, and this is what I stated, saying I wish they make it so no one can work on the floor below. But OSHA states you must send somebody down there to check the shoring, and immediately after concrete placing. But the person you send must be qualified, and this is what I put on my tag on in that last video, saying if they do it, it should be a qualified person. That's what I was trying to allude to. But now, as one of my continuing ed for law, one of the law classes I've taken stated, law enforcement classes, I'll give you that much. The instructor used to always say it's nice to be right, but it's better to have a sight. So what I told you was it was kind of nice to be right type thing, but now I'm giving you the sight. So it's nice to be right, but it's better to have a sight. That instructor was very serious about, you can say it, but now back it up. So I would back it up under 1926.703 B3. Erecting shoring equipment shall be inspected. So I'd back it up that I was allowed to send that man down there because he's a qualified, say he was. I don't know. Because he's qualified. That's going to be the qualification thing that's going to really matter in a moment. Shoring equipment, I try to ask the cousin who wrote on the link there. I try to ask her to ask the friend, was his friend qualified to do that? This is what would be the main issue here. Shoring, under the next section, is found to be damaged or weakened after erection, such as strength is reduced to less than required, shall be immediately reinforced. So they're stating that shall must be immediately reinforced. I think shell is wrong here. I think OSHA is putting people in danger. You'd rather walk away from that shoring than attempt to shore up something that's collapsing underneath you. Collapsing, it's actively moving. You'd rather call it a day, unless you know how to brace it, working your way up to it, not just jumping right to the middle of it, attempting to push it. You'd have to actually have training in how to reinforce that specific load, which I state to you that's not typical. That training would not be typical. I would argue that you'd have to first figure out that this was the part that was collapsing. You got to surround it, secure the area around so you can limit the collapse back to this new shear plane, as I like to call them. and then close that shear plane in. But imagine most people would just say, oh, it's buckling there or falling down there. I'm going to put a load right there. That's going to be pushing that load all around. It's not going to work. So I argue that this is actually an unsafe act by Osha stating you shall immediately reinforce. This is ridiculous. Shoring equipment that is found to be damaged, and this part here is important, weakened after erection, such as the strength is reduced to less than required shell. So after erection that is weakened. How do you know, now you say, well, he didn't say it was being poured. Bear with me. The sills for shoring shall be sound, rigid, that's the base plates, and capable of carrying maximum intended load. All right. All base plates, shore heads, blah, blah. Eccentric loads on shore heads. This is interesting, this part here, because all codes are subject to interpretation, meaning you could play with the interpretation of what they meant by it. And let's go for this, because they don't give you a more direct exactly what they're talking about. It's subject to the interpretation. Whenever single pole shores are used on top of another tiered, the employer shall comply with the following specifications required in addition to the general requirements for the formwork. What's the definition of tiered? I would almost argue that if you put a 4x4 on top of a 4x4, you just created a tiered section. The design of the shoring shall be prepared by a qualified designer, and the erected shoring shall be inspected by the engineer qualified in structural designs. This is this next subsection. So this part right here, where they said you inspect it, that worker now gets eliminated as far as I'm concerning, because the design of the shoring must be prepared by a qualified designer, and the erected shoring, that means the shoring that's already put in place, not must, there's a shell there, must be inspected by the engineer qualified in structural design. So this means your regular civil engineer guys don't really get because they want somebody that does structural design, qualified in structural design. This is that ambiguous part that of course, pretty much, what do they mean by structural design is the question. What is their definition of structural design? And all they pay was engineer and structural design. Well, electricians do structural designs of their steel work, right? Of their duct work sometimes. Mechanical engineers do it. They do that. So they're not being. You would think they would be talking about construction structural design of the materials that are being placed. This is I find this open, ambiguous here. But let's go on again to it. The design of the shoring shall be prepared by a qualified designer. So this means that the qualified designer for the materials, and erecting shoring shall be inspected by an engineer. So not the person that did it. It just wants another person that's qualified in structural design. So the person to design it is not necessarily the person that will be inspecting it, which is kind of an out, because this means you can outsource this to India, for example, and they get to do the shoring method for you, and then you can have your local person do your inspection. They never having a skill set to evaluate this properly, besides saying qualified in structural design, not actually knowledgeable of this particular design. This is what I'm driving at, is that you get to do some really stretching here on who you can hire to be part of a team to do this inspection. Let's move it on. The single post shores shall be vertically aligned. So that would be single post shores shall be vertically aligned. Vertically aligned. So what part is acceptable at a vertical? What part's acceptable at a plumb? The single post shores shall be spliced to prevent misalignment. The single post shores shall be spliced to prevent misalignment. Isn't that interesting? The single post shore shall be adequately braced in two mutually perpendicular directions at the splice level. So perpendicular. So when we see our man, is it right here? He sent me the images. These aren't. These are scaffolding right here. This one's not perpendicularly braced, is it? Unless somehow they braced it back to here, and you can consider the cross bracing on this scaffolding perpendicular, and then you'd have to go this way. But these are two. This is a splice system. Look, 1 and 2. This appears, I don't know if it goes down the ground or not. It appears not to go down the ground. I mean, that would be a lot of cutting. This appears to get its clamp, its leveling ability by the what I call lie backing technique, where it's the this bar, this 1, 2, and maybe a bar down there, transfers the load and locks it in friction. Same thing here, but there it is. It's not falling. It doesn't appear to be falling, hitting the ground. See how it doesn't hit the ground? So this is the splice, but the splice is up here, but I don't see that other bracing, the perpendicular bracing here. Remember, this is after the fact. Firemen moved a lot of stuff, as we saw in the other one, but when we saw in this other video, this other image, they used cross bracing. Remember the video number 3 on this? I think it is. You got to go there and find it. I talk about they use cross bracing and not perpendicular bracing. I don't see where OSHA allows for cross bracing. I see where they say perpendicular. Oh, great. I lost the, right there. Okay, here we go. Each tier shall be diagonally braced in the same 2 directions. Now we say diagonally. So first they say 2 mutually perpendicular directions at the splice level, and then we go here. Each tier shall be diagonally braced in the same 2 directions. So they want times 2. I mean, this is what I'm looking at. They want diagonal and cross bracing, parallel, perpendicular directions of the splice. I don't see that there. So just pointing that out. Adjustments of single shore shall be shores to raised formwork shall be made after the placement of concrete. Now, did you just see what the concrete weighs so much? This is the most stupidest thing I've seen so far. Adjustment of single shores. So there's single post shores. There's single. To raise formwork shall be made after the placement of concrete. Oh, I'm sorry. Shall not be made after the placement of concrete. So you can't raise it anyway. It's a single post. It's only one size. How are you going to raise a single post shore? Unless they're talking about the splice kind where you can crank it up like a threaded screw kind. Reshoring shall be erected. Reshoring. This is the reshoring part. Now you guys can think of this back at the hotel. Hard Rock. Shall be erected. So shall again. As the original forms and shores are removed. So as you remove one, you're putting back the reshores. Whenever the concrete is required to support loads in excess of its capability. All right, so this means that the concrete hasn't matured yet. This is what this means. Not that you're going to keep them in there forever. And we'll get to that. Vertical slip forms. Let me see if I can find that real quickly. I'm going to pause it and get it to you. Hold on. I know I'm looking for to show you when you can remove the forms. Oh, it's right. It's right here. I just. All right, removal of formwork. Forms and shores, except those used for slabs on grade and slip forms. So this is not slab on grade. These are elevated concrete pads. And they're not slip forms as in climbing up a wall. Shall not be removed until the employer determines that the concrete has gained sufficient strength. So the employer is the one that determines it, has gained sufficient, and he based that on has it gained sufficient strength to support its weight. So it has to support its own weight. meaning the deflection would be limited to what it was allowed, and superimposed loads, which means any material loads, etc., people walking loads, type things like that, working loads. Such determination shall be based on compliance with one of the following. Such determination shall be based on compliance with, what did I just say again? One of the following. Not all of them, just one. It can choose, you choose. The plans and specifications stipulate conditions for removal of forms and shores, and such conditions have been followed. So that would be one if it's in the plans. Or, see the or this version. The concrete has been properly tested with an appropriate ASTM standard test, that you have a sample and you test it and it states that it's good to go. To indicate the concrete compressor strength, and the test results indicate that the concrete has gained sufficient strength to support its weight and superimposed loads. That's it. So you don't have to wait, as everyone keeps arguing about, 1 day, 31 days, 15 days, and all this. This is the requirement, is one of the requirements. So you test it. You can have a test sample that says your concrete's met this PSI. The engagement in the steel, in this case, is where we need to be at this point. Yeah, it can mature to a higher PSI while it's at that point. Keeping in mind you stay under your restricted loads up here, that your loads that you plan on putting on it. Or this one. Reshoring shall not be removed until the concrete being supported has attained adequate strength to support its weight and all loads placed upon it. All loads in place upon it. Weight and all loads in place upon it. Whatever. So being placed upon it or on it or whatever. Just long as it can support it without deflecting more than acceptable deflection as far as whatever the span may be, whatever they consider deflection. I state that concrete is not flexural. Concrete's not flexural. It's not flexural. And that bending concrete back and forth, allowing to flex, like on a bridge structure, for example, is just breaking the concrete apart, piece by piece. Internally, all that friction, the stones rubbing against each other. But I don't like concrete in a flexural capacity, and I mean a flexural active capacity. Reshoring shall not be removed until concrete support has attained adequate strength. That's all that matters. You can remove it in 2 hours if you're using something like rapid set and you only need 4,000 psi. My gosh, let me go stop these cats. You hear them in the background? Yeah, there's no stopping those cats. As soon as I chase them away, break them up, they chase back each other. They chase and they want to play. And my one cat, he fights by screaming also, but he chases after him and says, "Let's fight." All right. This deals with we moved on to 701. Construction loads. This is important because of the loads they put on it on the top floor, etc. No construction load shall be placed on a concrete structure or portion of a concrete structure unless the employer determines based on information received from a person who is qualified in structural design again. So back to this person qualified in structural design. Not concrete, not steel, not specific to this structure. Just that they have a qualification in structural design. That the structure, so this is what you're allowed to do. You're allowed to, qualify somebody in structural design and say you're going to be my determining person. This is very interesting. That statement. They dropped the word engineer here. If you noticed, there's no engineer required here. It says a person who is qualified in structural design. And so, who's qualified in structural design? Structural design, so that would be designing of such, right? Or does it mean that someone who knows how to read structural design? It's ambiguous to me. It needs some cleaning up. All right, comma. The structural portion of the structure is capable of supporting the loads. So the person who is qualified in the structural design. Based on information from a person who is qualified in structural design, that the structural portion of the structure is capable of supporting the loads. So that would be a person that's qualified in structural design using Osha's requirements, saying, look, the concrete, we needed 4,000 per the plans. Our testing came back at 4,500. I'm the qualified structural design person based on those concrete. You can now load this out to what the floors will allow for, which would be whatever it may be, 50 pounds per square foot, 150 pounds per square foot. That's very important that you tell them the limits of what they can put on there loading it. Reinforcing steel, all protruding reinforcement steel onto. Okay, right now, let me move on. So under the same section, it says no employee shall be permitted to work under concrete buckets while buckets are being elevated or lowered into position. So you're not allowed to work under while it's being elevated or lowering. Once it stops moving, you can now work under it because it's not well are being because they are being elevated. That's an action movement, or being lowered. That's a movement. So when it's no longer moving, you can work under it. Of course, they don't state that there. OSHA is just lacking some clarity. This allows for your worker to work under there. This also allows for the worker to work under a floor of concrete above it. That might fall down. OSHA is not. This is just some. They need to clean their act up. Okay. Lastly, I'm sharing my source with you guys. This is my source. It's one of my OSHA friends. I wanted to make sure that what I was doing right, and he said, "Go to these instead." I went to somewhere else on the site, and well, I went to one of these on the site, and he wanted me to actually add all of this together on there, and so I'm giving it to you. This is probably what the OSHA will use with when they're referencing, is what he was basically explaining to me. They'll reference all of this and make sure that if any of the violations or all of this, including equipment operation, um, face shields, things like that. And of course, we don't have lift in place slabs, but I wanted to give this to you. There's one more link, but I can't share it because it exposes identity. So take care, guys.